All right, we're looking at this set of notes. I'm going to focus just on the bits that are most important for what we're supposed to do. One of the biggest things is in number two, when you're finding the average speed, you got to remember 1 hour, 2 minutes, 41 seconds is this, because 41 seconds out of 60 seconds in a minute is about 0.68 of a minute. But other than that, you just do miles divided by time. That gives you your miles per minute, about 0.107. But other than that, one and two are good questions for you to think about, but I'm not going to include in this video here. So here, Pamela's distance traveled with respect to time. How could you use this graph instead of your summary report, blah, blah, blah. Calculate average speed. Long story short, starting point, ending point, and you could go through and find the slope. Right, the slope between those 2 points is going to give you your average rate of change on this interval. Was she running at a constant speed? No, because the graph isn't a line. That's an idea we've come across a few times already the last few classes we've been together. Constant rate of change means line. The green graph not being a line means not a constant rate of change. At what time does it look like she's running the fastest? So at what specific single point does it look like she's going the fastest? Probably like right here, if we draw that little line segment like we've been playing with. That's where she's going the fastest. How can you tell? The graph is going up fastest. And so these two rates of change we've got over here, the slope of the big line is called an average rate of change. Okay, you might see this referred to in some places as AROC. Average rate of change is over a big interval. The rate of change at a single point is instantaneous rate of change. Which you could see referred to as IROC. So, how do you think Fitbit's able to capture a current speed at any time during the run? The idea you're getting at there, rate of change is just slope formula. Rate of change is always going to be change in y over change in x. So it is y2 minus y1 over x2 minus x1, meaning you need 2 points. You need 1 point, 2 points. So to get the slope at a single point, you still need 2 points. So how would Fitbit do that? You would just take 2 points very close to this, right? So if I wanted the instantaneous rate of change right here, I would go like from here to here. So 2 points very, very close to the one that we're curious about, and you just find the slope between those two. So then those big ideas for this set of notes is just average rate of change versus instantaneous rate of change. Average rate of change, if I have a graph, I'm going to go from one point to another point. I'm going to draw what's called a secant line. And I just want to find the slope of that line. So let's say we go from A to B, and that my function here is f of x. Then I would be able to say that my average rate of change, AROC, AROC, is just y2, whatever f of b is, minus y1, whatever f of a is, all over b minus a. Okay, just the slope of that secant line. Whereas instantaneous rate of change, like we saw on the other side of this sheet, if I have a function like this, instantaneous rate of change is just going to be the slope of a line through that single point. This is called a tangent line. But That's just going to be the slope at one specific spot. So largely, I want you and your groups to do these check your understanding questions. I'll have the answers posted on Canvas for you to check against. I'm not collecting them. This is just to see if you understand sort of what's going on, right? What is happening. But the one I'm going to focus on here to get at this idea of instantaneous rate of change is it asks us in 1b, estimate the rate at which the temperature of the tea is changing at t equals 3.5. So we need a slope between 2 points. When t is 3.5, which 2 points should we use? You're just going to use whichever two are closest. So my t values 0, 2, 5, 9, 10. Which two are going to be closest to 3.5? The 2 and the 5. So then that rate of change is just going to be taking these 2 points and doing the slope between them. So 52 minus 60 over 5 minus 2, which is negative 8/3, is my rate. And what's changing is degrees Celsius per minute. So that one I wanted to show just to illustrate that instantaneous rate of change is still the slope between 2 points. You just want to take the 2 points closest to whichever value you're looking at, right? Other than that, work on these, check your understandings, check the answers on Canvas to see if you're right, you're not right, talk to each other, figure it out, and then there's going to be the homework assignment to go with this and the next set of notes. These ones right here, okay? So the last set of notes focused on rate of change kind of broadly. What is an average rate of change? What is an instantaneous rate of change? This one's going to focus on rates of change in linear functions specifically. So we're going to kind of hop through all the different types of functions, and we start with linear functions. So we've got cost of renting a U-Haul for a certain number of miles driven. So what is the average rate of change in the cost of the rental between 10 and 25, right? So this first row here, third row here. So that's going to be 42.24 minus 28.89 all over 25 minus 10, all of which comes out to be about 89 cents per mile. What is the average rate of change between 25 and 50? That would be here and here, same sort of setup. 64.49 minus 42.24 all over 50 minus 25, and that ends up being about the same thing, 89 cents per mile. So graph the points, these points right here. So if I graph those points, they all appear to be more or less on a line, right? Which shouldn't be surprising. I said this set of notes focuses on linear functions. These points make up a line. So what does the graph reveal? It is a linear relationship. So is the rate of change of cost increasing, decreasing, or staying constant? Constant. Lines have a constant slope. And that slope is our rate of change. So U-Haul charges all its customers a minimum base price, blah, 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 blah. What is this base price? We can pick any of these. Let's take 10. 10 miles, 28.89. So we know those 10 miles cost 89 cents per mile, which is $8.90. So then what is the base price? It's that total cost of the U-Haul minus the $8.90, so it is $19.99. Okay, and then an equation for this, since it's linear, we can just go with y equals mx plus b, slope-intercept form. Slope is 89, and we don't want x, we want m. And then our y-intercept is that base price we just found. So that's how we can get the equation. So the nice part about the big ideas here are they're things we've talked about. Linear functions have a constant rate of change. That's an idea we've repeated back a bunch now. Secondly, the rate of change is constant, so the rate of change of the rate of change is zero, which is analogous to saying like the acceleration is zero. Your rate of change is constant. Whatever the slope of your line is, it's not going to change, which also means there's no concavity. The rate of change of our rate of change is never positive, nor is it negative. So we're never concave up, nor are we ever concave down. That acceleration is always zero, no concavity. And then the third thing is just to specify that that constant rate of change is the slope. Right, so just making sure that that is clearly stated, that lines have a constant rate of change, great, and that constant rate of change is the slope of the line. So anytime you're talking about rate of change with anything linear, that rate of change is just going to be the value of the slope. So then similar to the first set, do these, check your understandings, check the answers in Canvas, make sure you understand them, and then you can move on to the Delta Math. But I wanted to highlight number 2 because they give us this and ask us for the rate of change of f. Right, we know it's linear, so the rate of change is constant, but this, they've basically told us y2 minus y1 is negative 27. They've told us that x2 is 4 and x1 is 1. So this is one that people have still been coming to me with questions about, which is totally fine. Continue to do that, please. But function notation is just something that's not a high comfort level for a lot of people. F of 4 is saying the x value is 4. What is the y value, right? So for 4, what is the y value? F of 1 is saying the x is 1. What's the y value when x is 1? They're not telling us what those y values are. I don't know y2 and I don't know y1, but I know the difference between them is negative 27. And all of that allows me to find the slope is y2 minus y1 is negative 27 over x2 minus x1 is 3, so my slope is negative 9. So that's my rate of change. F11 minus f of 8, there are 3 spaces between 11 and 8, just like there are 3 spaces between 4 and 1. So since this is a linear function, this change should be the same as that change. That should be negative 27. And then part C, f of 20 minus f of 15 all over 5 is the same as having f of 20 minus f of 15 all over 20 minus 15, which is the slope of the line, which is negative 9. So 2 is a bit of a tougher question just because they're giving you the information in kind of a weird way. But it is, again, just harping on the idea that the slope of the line is the rate of change and that that rate of change is constant. So it doesn't matter which x's you're moving between, the total change should be the same. And then it doesn't matter which 2 points you use to calculate slope, the rate of change should be the same.